All right, so moving on, let's next take a look at rigid motion. So rigid motion is going to be an idea that carries throughout Unit 1. Now, rigid motion, let me move this up here for you. Okay, a rigid motion is a transformation that changes the position of a figure without changing the size or shape of the figure. Hence, why I kept asking if it changed the shape or size. Okay, because that's going to relate to rigid motion. Okay, translations, reflections, and rotations are rigid motions. Dilations or stretches are not rigid. Okay, now these are different properties of rigid motions. So it preserves distance, angle measure, betweenness, collinearity, and parallelism. Okay, these two are a little more confusing. Just know that rigid motion preserves distance, angle measure, and betweenness. Know this. Okay, translations, reflections, rotations are rigid, and rigid motions maintain shape and size. If it does not maintain shape and size, it's not rigid. And an example of a not rigid motion is that where we made it larger or smaller, that is not rigid. So whenever you multiply or divide to x or y, know that that is not a rigid motion. All right, so now we can finally go through and jump into our first example. So example 1 is going to ask us to use coordinate notation to write the rule that maps the pre-image to its image. Identify the transformation, then confirm it preserves length in angle measure. So let's go through and take a look at this. All right, so the first part is they're going to ask us to write the rule using coordinate notation. So we're going to use coordinate notation to write the rule that takes the pre-image and it's going to map it to the image. So we want to take this triangle and place it here. Now, the way that I suggest you do this, okay, is we're going to look at the values of x and y, and we're going to see what changed from these x values to these ones, and what changed from these y values to these ones. So coordinate notation is always going to start with x comma y, and then it's going to go to whatever the change is. So if we look at the x values, for D, it's -4, E is 2, F is -4. So -4 to -4. The image for D prime is 4, E prime is -2, and then F prime is 4. So how do we get from -4 to 4, 2 to -2, and -4 to 4? Now, you could go through and add numbers to get to each of their images, but it has to be the same thing each time. So if I add 8 to -4, it does get me to 4, but if I add 8 to 2, that does not take me to -2. Okay, that takes me to 10. So adding is out of the question. Okay, in this case, all that has changed from the pre-image to the image is the signs, meaning negative to positive, positive to negative, negative to positive. So we represent that by just putting a negative in front of x. All right, then if we look at the y's, so we go from 4, 4, and 1 to -4, -4, and -1. So I went from positive to negative, positive to negative, positive to negative, meaning my sign changed. So we're going to represent that by a -y. So my coordinate rule is going to be x comma y goes to -x comma -y. So that is my coordinate rule. Now, the transformation, okay, if we look at going from here to here, okay, this did not flip, okay, even though I know it looks like it flipped, it did not. And then if we look at a translation, okay, there's no way that I could get it to be the same orientation. This is in fact a 180-degree rotation. Okay, we rotated the figure. And when we get to Module 2, we'll talk about how to identify that that was a rotation and so on. All right, now the problem asks us to go through and confirm it preserves length and angle measure. Really what I want you to do with this is to just take a look at the shapes. Okay, does it appear that they maintain that same shape and size? Okay, you could go through and count the different sides that are perpendicular or parallel right on the grid. And it helps to figure out these lengths. You would have to go through and actually use the distance formula. If you want to see how that's done, it is on my completed notes. I'm going to show you just real quick right here. Okay, what it is. It does preserve shape and size. So that does confirm that this is a transformation, that is a rotation. So if you want help and guidance on how to figure that out, okay, you would have to use the distance formula and some counting to do that. I'm not going to do that for a matter of time in here. If you need help with it, just let me know. All right, so let's take a look at one more example of this, and then we'll move on to example 2, and then be done for today. All right, so part B. So we have our pre-image points and our image points for STU, and then S prime, T prime, U prime. Now, again, the first thing we need to do is go through and figure out the coordinate notation rule. So it's going to be x comma y goes to, and then that is our goal. So let's take a look at the x's first. Let's try to go through and identify the pattern. So we're going from -3 to -2, from 2 to 3, and then -2 to -1. So ask yourself, what can I add, subtract, multiply, or divide to get me from -3 to -2, 2 to 3, -2 to -1. So if you think about what you can do to get those points from the pre-image to the image, in this case, all I need to do is actually add 1 to the x values. So if I do x plus 1, okay, -3 plus 1 is -2. 2 plus 1 is 3, and -2 plus 1 is -1. So x plus 1 is going to be my first step. All right, if we take a look at the y values, so I go from 4 to 2, 4 to 2, and then 0 to -2. So ask yourself, what can you add, subtract, multiply, or divide to 4 to get to 2, and then 0 to -2. So in this case, all I need to do is go through and subtract 2 to all the y values. Because if I do 4 minus 2, I get 2, and 0 minus 2 is going to give me -2. So my coordinate rule, my coordinate notation rule, is going to be x comma y goes to x plus 1 comma y minus 2. Now, this problem, okay, if we look at our pre-image and then our image, all we have done is slide the shape down to here. And way of thinking about a slide, and more of a fancy term, is a translation. Okay, all we did was move it 1 unit to the right and then down 2. And that is a translation. For this type of transformation. So anytime that the shape maintains orientation, size, and shape, but it's just been moved to a different spot, that is a translation. All right, now this part again would ask us to go through and determine if it preserves length and angle measures. Angle measures, you go through and use a protractor. For the lengths, you have to go through and use the distance formula for it. Okay, just by looking at these two, do they appear to preserve shape and size? In this case, they do, because again, a translation preserves shape and size. All right, so both of these examples are rigid motions because they maintain shape and size. And that matches what we talked about with rigid motions because a translation, rotation, and a reflection are all rigid motions. All right, so let's move on to our last example for today, and that is where we're going to end up with example 2. Now, before we jump into example 2, transformations that stretch or compress figures are not rigid motions, like we talked about with that example right before rigid motions, because they change the distance. Okay, so there's those different properties of rigid motions. You have to maintain distance, and that's going to be violated when you go through and stretch or compress figures by multiplying and dividing. All right, so example 2 is going to ask us to use coordinate notation to write the rule that maps the preimage to its image, and then confirm that it is not a rigid motion. So again, we have to go through and write our coordinate notation rule. So we're going to start with x comma y, and then that's going to go to our new rule. So if we take a look at our preimage points for x, so it's -4, -2, and 0. And then our image points are 4, -2, and 0. Now, if we look at the change, so 4 to 4, -2 to -2, 0 to 0, nothing has changed between these points. So that means we're just going to leave the rule as x because nothing has changed. Now, if we want to look at our y values, to go from 1 to 3, -1 to -3, and then -3 to -9. Okay, ask yourself what you have to do to those y values. What do you have to multiply, divide, add, or subtract? So to get from 1 to 3, we'd have to multiply by 3. And the same is going to be the case for -1 to -3, -3 to -9. So in this case, I have to multiply by 3. So that means we're going to have 3y as our answer here. Now, in this case, this is going to be a dilation or a stretch. So this is our coordinate rule. This is a stretch, so it's going to make the figure bigger. And like we talked about up here, anytime that it stretches or compresses the figure, it is not a rigid motion. So, this is not rigid based off the fact that we have multiplied. So remember, anytime you multiply or divide, that is not a rigid motion. Okay, adding, subtracting, changing the sign on x and y, that is all rigid. But when you go through and multiply, like in this case by 3, that violates rigid motion, so it is not rigid. Now, you can go through and prove it to be the case. Again, you have to go through and use the distance formula. You can look at my completed notes for guidance on that. Just to give you a quick look, if I do that, okay, my distances for the side JK has changed from the square root of 40 to the square root of 72. Okay, if you want guidance and help on how to do that, and if it pops up in the homework, it's not something you're going to have to worry about on the quiz. All you really need to worry about on the quiz is how to go through and transform shapes in terms of the points where you add, subtract, multiply, divide, or you have a negative sign. That is all you need to know for the quiz. How you transform the points from its image to its preimage, and then what it looks like on the graph, and then if it's rigid or not. Okay, you don't really necessarily have to worry about writing the rule on a quiz, so don't fear too much on that. Just feel comfortable about how to identify the rule though, because it is helpful in the future, just by looking at the pattern and what's changed from the preimage to the image. And then just know that a translation, a reflection, and a rotation is rigid. A stretch or a compression in regards to a dilation is not rigid. So that means whenever you multiply or divide, it's not rigid. Add, subtract, or changing the sign is rigid. All right, now there's parts B, C, and D. I will leave those for you guys to take a look and practice. If you would like to see how those are done, you can take a look at the completed notes, or you can always ask me next time that you see me, and I'll be more than happy to help you however I can. All right, so with that said, that is it for section 1.3. I hope you feel fairly comfortable with what we've talked about today. If you have any questions, as always, just ask me later, and I will be more than happy to answer however I can. So, that is it for today. Thank you for listening, and I hope you have a great day.